So hello friends, welcome back to my YouTube channel. So in this video I will be starting a new playlist on linear algebra. Before I start my explanation, let me first tell something about this course. Now the course code of this course is ASS 31063, right? So which means this is offered in level 3 in first semester 1, and this is the number assigned to the course, and it has 3 credit. So this is a 3 credit course. Okay, so the course name or the course title is matrix algebra, but I'm going to call it as linear algebra. Okay, right. So linear algebra, throughout this course we will be talking about matrices and vectors. Oftentimes we will be talking about matrices and vectors. Okay, right. So it has 7 chapters, as you can see on the screen. Chapter 1, Chapter 2, Chapter 3, Chapter 4, Chapter 5, Chapter 6 and Chapter 7. After completing the Chapter 7, we will be having 5 tutorial discussions, right? Okay. So in the first chapter, we will be completely talking about vectors, and in the second chapter, we will be purely talking about matrices, and in the later chapters, starting from chapter 3, we will be combining matrices and vectors and talk some theories related to both matrices and vectors. Okay, so let me first start with the chapter 1. Okay, so the chapter 1 is all about vectors, right? Okay, so there are 2 types of quantities. We have just studied these things in our earlier classes also, right? So there are 2 types of quantities. So first we have to know what a quantity is. So if I write a definition for quantity, it is a measurable attribute or characteristic that can be represented numerically, right? So a measurable attribute or or characteristic that can be represented numerically. So this is just a basic definition for quantity. So we can say it's just a value, right? It's just a value. So typically we have 2 types of quantities. First one is scalar and the other one is vectors. So scalar means it has only magnitude. Magnitude means value, right? So it has only value. But vectors have both magnitude and direction, right? So vectors have both magnitude and direction. And we have already studied some examples for these scalar quantities. For example, temperature. Then we studied about like mass, then distance. So these are some examples for scalar quantities. And for vector quantities, we have studied displacement and mass. So here weight can be a vector quantity because it has a direction also. And for example, velocity, right? So these are vector quantities. Now there is a note. Vectors can be represented geometrically as directed line segments arrows in 2 space or 3 space. So we are going to be discussing about vectors. So vector is extracted or denoted or represented in vector space. Okay, right. So we have already studied that vector is anything that has magnitude and direction. So vectors in Rn, right? So this is what Rn is, some dimension of real space, right? So here we are going to be talking about n tuples. So what is n tuple? So n may take values starting from 1 to infinity. So 1 to n we can say, right? So if it is one tuple, then we will say that is a single element. Okay, so an n tuple is written within parentheses, right? So we will see what an n tuple is. So an n tuple is a sequence of elements, right? So it can be a sequence of elements written within parentheses. So if I want to tell a definition for n tuple, it's a sequence of numbers or elements written within parentheses. So if we have one tuple, then we have only one element, so I can write this way, A. Then if I have a two tuple, then it is called pair, ordered pair, right? So I can write A comma B, but I have to write A and B within parentheses. Then if we have three tuple, then three tuple is called triplet. Then it can be written as A comma B comma C. So A, B, C are called elements. Now the set of all n tuples of real numbers denoted by Rn is called n space. A particular n tuple in Rn, say u is equal to a1, a2 all the way to an, is called point or vector. So here it is a point or vector, right? So if we have a vector 2D vector, we have 2D vector and 3D vector, right? So we will be discussing the differences between 2D vector and 3D vector now. Okay, right. So now we will classify 2D vector and 3D vector. 2D vector and 3D vector. Right. So 2D vector means we have two tuple and here we have three tuple. Right. So here 2D vector is represented in two-dimensional Cartesian coordinate system, and it can be expressed as V, if I denote using a letter V, is equal to x comma y, right? So this is horizontal component, and this is vertical component. Now we will see how we can denote this vector on Cartesian plane, right? So let's say this is our Cartesian plane, this is our x-axis and this is our y-axis. Okay, so x comma y, so let's say this is the value for x and this is the value for y. So if I take an example, a is equal to 2 comma 3, then from the origin horizontally I have to move 2 units, right? So this is 2, and vertically I have to move 3 units. Let's say this is 3, and if I denote this point, and this will be my A. Okay, right. Now 3D vector. Now we have already discussed about 2D vector. Now if I say B is equal to -2 comma -3, then it means in the horizontal axis, in the x-axis, I have to move 2 units left side because the sign is negative, right? So here let's say this is -2, and in the vertical axis also I have to move downwards since the sign of the vertical component is negative. So let's say this is -3, So this will be my B. Okay. Now we will be talking about 3D vectors, right? And visually this will be a plant, right? So this will be a plant because we have only two coordinates, two axes, right? So since we have only two axes, this will be a plant. Now 3D vector, so 3D vector will be a space, right? So we will be having three axes. So here v, so if I represent the vector using the letter v is equal to x comma y comma z. So what is x? X is the component along the x-axis, component along x-axis, and y is component along y-axis, and z is component along z-axis, right? Now if I take an example of C, vector C, right? So I have to put a line below this letter to represent or to mention that they are vectors. So C is equal to, let's say, 2 comma negative 1 comma 5, right? So this will be graphically represented this way. Let's say this is x-axis and this is y-axis and this is z-axis. So along the x-axis, the first element indicates the component along x-axis. So since the sign is positive, I have to move right side along the x-axis, right, in the positive direction. So let's say this is 2, and if you look at the y component is negative. So if this is y, so this is also y, but this is negative y. So here one unit I have to move along the y-axis in the opposite direction, in the negative direction. And z-axis, in z we have 5. Let's say this is z and this is my y. So if I mark this point, that will be my C vector, right? And then the point, right? So the point is in the space of this 3D coordinate, and if I join the origin and that point, it will represent my vector C, right? Now these are just some clarification about 2D and 3D vectors. Now we will move to vector addition, right? So these are very simple concepts, and here we have some other notes also. We will just look at them. The numbers a, I are called the coordinates, right? So basically these are called coordinates. We have already studied x comma y. So for example, in the Cartesian system, we have a point like this, and these are called x comma y is called the coordinate, right? And components, these can be called coordinates or components. As I told you, this is the horizontal component and this is the vertical component, and we may say entries or elements also, right? Okay, now if the all elements in a vector is 0, then it is called a zero vector, and it can be denoted using this notation, zero vector. Now we will see how we can add two or more vectors together, right? Let me create some space here. Right, vector addition. Let two vectors u comma v in Rn. So if we are taking a vector from 2D space, then we will denote u comma v belongs to R square, because this is a 2D space. This will be 2D vector. And if we have vectors from cube, then u comma v belongs to R cube, then it will be a 3D vector, right? Okay, now vector addition. Now vector addition mean we will be having different vectors and we have to add the corresponding elements, right? So here you see, if we have u and v and u is equal to a1 comma a2 up to an, and v is equal to b1 b2 up to bn. Now we have to add the corresponding elements, right? So the corresponding elements mean the x, the component along x-axis in the first vector and the component of x-axis in the second vector. So we have to add a1 and b1 and a2 and b2 up to an and bn. So u plus v will be equal to a1 plus b1 comma a2 plus b2 comma up to an plus bn. So this is called vector addition, right? So let two vectors, say u is equal to this and v is equal to this, their sum written u plus v, right? So the sum or the addition of these two vectors can be written as u plus v, and the elements of this u plus v will be the addition or the sum of the corresponding elements in the vectors, right? So u plus v is this. Now we will be talking about scalar products. So scalar product, we are going to take a vector u belongs to Rn. So u belongs to Rn means you will be having elements from a1 to a1 comma a2 up to an, right? So it has n elements. Now if we take a real number k, then again k belongs to real number written by k into u, right? So now we are just multiplying this vector u by k, then we have to multiply each element of vector by k, right? So ku will be equal to ka1 comma ka2 comma ka3 up to kan, right? So this is called scalar product. Okay, the next thing is we have a knot. Now u plus v comma ku are also vectors of Rn, right? So if you take u and v from Rn, then the results of or the resultant vectors of u plus v and ku also will belong to this vector space, right? So negative u is equal to negative 1 into u. Now this is nothing but we are just negating the components of the vector u. Then u minus v is equal to u plus v. So we will be talking about this knot now. What does it say? So for example, let's say this is u and this is v, then u plus v will be the vector of the starting point of u and the ending point of v, right? So this will be u plus v. Now u minus v means, now this is u, right? So negative v will be the opposite of positive v. Then we have to just extend this line in the opposite direction, but with the same length. So this is negative v. So u minus v means u plus negative v, right? So we will be joining the starting point of u and the ending point of negative v. So this will be u minus v. Okay, right. Now we will do this example. Let u is equal to this and v is equal to this and w is equal to this. Find 3u minus 4v, right? So here 3u means we have to use scalar product here, and minus 4v means again we have to use this scalar product, and then we have to subtract the corresponding elements. So 3u minus 4v can be written as 3 into u is this 2 comma minus 7 comma 1, 2 comma minus 7 comma 1 minus, then again 4, v is minus 3 comma 0 comma 4. So if I multiply, this 3 should be multiplied by each of the components in the matrix u, and vector u, and the 4 should be multiplied by all components in vector v. So 3 into 2 6 comma minus 21 comma 3 minus 12 right, minus 12 comma 0 comma 16. Now we have to subtract the corresponding elements. So 6 minus into minus 12, 6 plus 12 comma minus 12 plus 0 comma 3 plus 16, 3 plus 16. Now this will be equal to 18 comma minus 12 comma 19. Oh, I made a mistake here. So you see this minus into minus, minus into plus negative, so this will be minus 16, so it is supposed to be negative 13, right? So just we are adding or subtracting the corresponding elements. Now we will move to the B part. Right. Before moving to the B part, let me explain A first. A is equal to 3u minus 4v, right? So here first we have to perform scalar multiplication, and then again for finding 4v, again we have to find or perform scalar multiplication, and then the resultant vector should be subtracted, right? Okay, so 3 into u is 2 comma minus 7 comma 1 minus 4 into v is minus 3 comma 0 comma 4. So 3 into 2 6, then 3 into negative 7 minus 21 comma 3, then minus 4 into negative 3 minus 12, 4 into 0 comma 0 comma 16. Right, now this 6 should be subtract, this minus 12 should be subtracted from 6, which means 6 minus into minus plus 12 comma, again consider this minus 12 and minus 0, so minus 21 plus 0 comma 3 minus 16. So the answer would be 18 comma minus 21 comma minus 30, right? Okay. Then now we will move to the B part, which says to do this sum. B part, 2u plus 3v minus 5w, right? Again you see here we have to perform 3 scalar multiplication, and the resultant vector should be added and then subtracted, as in this expression. So 2 into u is 2 comma minus 7 comma 1 plus 3 into v is minus 3 comma 0 comma 4, and minus 5 into w is given as 0 comma 5 comma minus 8. So 4 comma minus 14 comma 2 plus 3 into minus 3 minus 9, 0 comma 12 minus 0, 25 comma 40. So if I add them together, 4 minus 9 minus 0 comma minus 14 plus 0 minus 25 comma 2 plus 12 minus 40. So if I simplify them, minus 5 comma minus 29 comma it is supposed to be 54, so it is supposed to be plus, yeah, okay. Again you see here, minus 8 into 5 negative 40, so negative into negative positive, right? So 54, this is the answer. Okay, right. Now if the vector p1 p2 has initial point p1 and terminal point, the ending point p2 is this, then p1 p2 can be written as p1 p2 vector can be written as p2 minus p1. So p2 minus p1 mean we have to write like this: p2 means x2 comma y2 comma z2 minus x1 comma y1 comma z1. Let me erase all these things so that you can clearly understand. Right. So here you see p1 p2 vector can be written as, now this is, let's say this is p1 and this is p2. The coordinates of p1 are x1 comma y1 comma z1, and the coordinates of p2 are x2 comma y2 comma z2. Then p1 p2 vector, so this will be p1 p2 vector, so this will be written as p1 p2 vector can be written as p2 minus p1. So p2 minus p1 mean that is nothing but x2 comma y2 comma z2 minus x1 comma y1 comma z1. So x2 minus x1 comma y2 minus y1 comma z2 minus z1 will be the vector p1 p2, right? Okay, now we will try to do this example. Okay, so find the components of u and v, u plus v and u minus v for the vector shown in the below figure. So this is u and this is v, and we have to find out the coordinates of these vectors. The components are, let's say, ux and uy. Let's say this is ux comma uy, then let's say this is vx comma vy, we have to find what ux and uy are and what vx and vy are. So let's take the length of this vector is r, right? So now u is equal to, now we will find the coordinates of this ux and uy in terms of r. So ux will be this, so this is ux and this is uy, and this will be vy and this will be vx. So if I fold this line through this 30-degree, then it will be ux will be equal to r cos 30-degree and uy will be equal to r sin 30-degree. Right? So this will be equal to r square root of 3 by 2, then this will be equal to r by 2. Then now we will find vx and ux. So vx, I'm sorry, right, the components of vector vx will be equal to this, if this is r and this is also r, since this is a circle, the radius will be constant, right? So the distance between the circumference and the origin, because we have constructed a circle based on the origin, right, keeping the origin as the center. Vx is equal to r cos 60, then vy will be equal to r sin 60. So this will be equal to r by 2 and this will be equal to square root of 3r by 2. Now they have asked to find out the components of u plus v and u minus v as well. So u plus v will be equal to, u is square root of 3r by 2 comma r by 2 plus v is r by 2 comma square root of 3r by 2. So this will be equal to, you have to add the corresponding elements of vector u and vector v. So this will be equal to r by 2 into square root of 3 plus 1 comma again r by 2 into square root of 3 plus 1. Okay, right, this is u plus v, and again u minus v means here you have to just replace minus for u minus v. Hope you have understood this example. This is nothing. We have a lot of things to study further. We will go to them now without spending much time here. So our next topic will be linear combination of vectors. Right. So linear combination of vectors mean, let's say we have a vector v, right, and we have some other vectors u1, u2, u3 up to un like this, right? Okay, now what I have to do is I have to write the vector v as the linear combination of u1, u2, u3 up to un, which means starting from here, starting from the starting point of vector v till the terminal or ending point of v, I have to write the linear combination of the rest of the vectors. Now if I use a different color, then you can understand this. Now if I start from the starting point of vector v, and if I draw a parallel line to u1, this will be something like this, and then again from here I have to draw a line parallel to this u2, and then from here I have to draw a line parallel to this u3 and all the way to the rest of the vectors, and then finally if I draw a line like this, right? So starting from here to here, v is equal to this plus this plus this plus this. So what is this? Since this is a parallel vector, this will be nothing but a scalar product of c1 into u1, and this will be c2 u2. I am just scaling the vector u1 by a scalar c1 since they are parallel. And here, for example, we have already studied, if this is a vector v, and if I draw a vector parallel vector to v, and this will be equal to lambda v, right? So if the lambda is greater than 1, then this vector will be the length of the vector, the second vector will be the length of the second vector will be higher than that of the first vector, and if it is 1, then the size of these two vectors will be equal, and if lambda less than 1, then the second vector will be smaller than the first one. Okay, so this is c3u3 and this is cn so v can be written as v is equal to c1u1 plus c2u2 all the way to cnun, right? So this is what they have given here. So let the vectors u1 u2 u3 up to belongs to Rn. So in the vector space we have taken m, right? How many vectors have we taken? M number of vectors, and from the real numbers we have k number of scalars. Then v can be written as the linear combination of the vectors u1 u2 up to So this will be v is equal to k1 u1 plus k2 u2 all the way to km right? Okay, when we do questions you can easily understand. Now we will be talking about column vectors and row vectors. So vectors are n tuples. Now they can be written either vertically or horizontally. If the elements are written vertically within parentheses, then it is called column vector, and if they are written horizontally, then they are called row vectors, right? So this is column and this is row. That's all. Now we will do this example. Right. So the example, write the vector v is as a linear combination of vectors u1, u2 and u3. So v should be written as the linear combination k1 u1 plus k2 u2 plus k3 u3. Now v is given 1 2 5 anyhow this is given as row vector, but let me write it as row vector itself. 1 comma minus 2 comma 5 is equal to k1, u is given as 1 comma 1 comma 1, then plus k2 is equal to k2 into u2 is equal to 1 2 3, then k3 plus k3 into u3 is equal to 2 negative 1 1. So now I have to distribute these scalars within these vectors. Then it will be like this: 1 minus 2 5 is equal to k1 plus k2 2k2 2k3 oh 3k2 plus 2k3 minus k3 plus k3, right? Okay, I have just distributed these scalars. Now I have to add the corresponding elements or corresponding components. So this is for x, this is for x, again this is for x. So k1 plus k2 plus 2k3 comma, the next one is y, this one, this one and this one. So k1 plus 2k2 minus k3, then component of z axis. So k1 3k2, then k3, k1 plus 3k2 plus k3. Now if you look at this, now this is a component along x-axis and this is component along y-axis and this is component along z-axis. So now again this is component along x-axis, so I can equate if this and this are equal, then this should be equal to 1, right? So k1 plus k2 plus 2k3 is equal to 1. Then again if I equate the y component, k1 plus 2k2 minus k3 is equal to minus 2, then k1 plus 3k2 plus k3 is equal to 5. Now we have 3 equations and 3 unknown variables. So if you solve these 3 equations, we can find the value for k1, k2 and k3. For this we can use our calculator rather than doing or solving these questions manually. So if you are using Casio FX991ES Plus calculator, then I will show you how you can find the values for these simultaneous equations. Right, so let me go to the calculator. So this is our calculator. Right. We have to solve this system of equations. So this is the step that you have to follow, right? So first you have to turn on your calculator. Then if you go to mode, if you press this mode without pressing shift, right? So if you press shift, then it will go to setup, but you have to press this mode without shift key. Then it will give you 8 options, and if you look at the 5th option, there will be it will appear EQN, which means equation, right? So press 5 now, and it will return 4 options now. So first one will be ANX plus BNY is equal to CN. Then second one is ANX plus BNY plus CNZ is equal to DN. So if we have 3 variables, we have to select the second option. Now press 2. So now it will give you display in which you can enter the coefficients of these variables, right? So the coefficients of variables should be entered in the calculator. So here we have 1, here we have 1, here we have 2, then here we have 1, Cn, right? So the format of the equation is ANX plus BNY plus CNZ is equal to dn. So these are the coefficients they are asking for. If you press 2, then A is asked, B is asked, C is asked, and D is also asked. So now the coefficient of the first the coefficient of k1 in the first equation is 1. So now type 1 and then equal symbol, then 1 again, the coefficient of 1 is 1, so again press 1 then equal symbol, then it will type the value under the B column, and since C is 2, type press 2 and then equal symbol, then D is 1, then now it will go to the second row, the cursor will go to the second row, which means we have to enter the coefficient of the variables in the second equation. Okay, so since we have 1 in front of k1, 2 in front of k2 and negative 1 in front of k3, now 1 equal, then 2 equal, press, right, then minus 1 equal, then D is negative 2. Then it will, the cursor will go to the third row, where you have to feed the coefficient of the variables in the third equation. 1 equal, 3 equal, then 5 equal. Now if you, after entering all these coefficients and the constants, again you have to press equal, then it will give you the value for x. So x is equal to x is equal to 11 divided by 9. Then if you press equal symbol again, y will be given, y is equal to minus 4 by 3. Then again if you press z, then 5 by 9. So our x is k1, our y is k2, and our z is our k3. So we have found out this value. I think I made a mistake while constructing or while finding out this equation. Anyhow, I hope you have understood how to do it, and in the second question you will understand clearly how we have to do this. Okay. Now the second question, we will move to the second question now. Anyhow, let me do the first question again and get the correct answer so that you can compare your answers with mine. And still, if you got a different answer, please do comment your values in the comment section. Okay, so now V is equal to let's say k1 u1 plus k2 u2 plus k3 u3, k3 u3. Now V is equal to 1, negative 2, 5 is equal to k1, u1 is equal to 1, 1, 1 plus u2, k2 u2 is equal to 1, 2, 3 plus k3 2, negative 1, 1. So now 1 is equal to k1 plus, I am just equating the corresponding entries in each vector. So 1 is equal to this is multiplied k1. Again, if this and this are multiplied, k2. Then again, if this and this are multiplied, 2k3. So 1 is equal to, after that I have to add, right? So I have to add. So k1 plus k2 plus 2k3. k1 plus k2 plus 2k3. Then negative 2 will be equal to, negative 2 will be equal to the sum of the the sum of the y components in the scaled vectors, right? So k1 plus 2k2 minus k3, then again 5 will be equal to k1 plus 2 3 k2, because this and this are multiplied, then again k2 and 3 are multiplied, then again k3 and 1 are multiplied, and k1 3k2 plus k3. So if they sum these three, then I will get k1 plus 3k2 plus k3, right? Okay, now if I go to your calculator again and enter these values, then you will get the answer for k1, k2 and k3. Let me try it again, and following the steps I explained previously, you also can perform this calculation, and then we will check if our answers are correct. 1 make sure that you have to first enter the coefficient of k1 under a, and coefficient of b should be typed under b, and coefficient of k3 should be typed under c. And here we have taken k1 as x and k2 as y and k3 as y. Ultimately the calculator will show the results for x, y and z, and then we have to transform them to k1, k2 and k3. Now 1 equal 2 equal 1 equal 1 equal 2 equal negative 1 equal negative 2 equal 1 3 1 1 3 1 5. Okay, so k1 x is equal to k1 is equal to minus 6, y is equal to k2 is equal to 3, and z is equal to k3 is equal to, if you press equals button again, it will be 2. So these are the answers. Now we will move to the second one. Write the vector v, this question, right? This question. I hope you have understood this question, and while doing these kind of questions you have to be very careful, because the probability of making errors will be high, and if you make a small mistake, then your entire life will be ruined. Right, moving to the next question. So we write vector v as a linear combination of the vectors u1, u2 and u3. For this type of question we will be later on studying about Fourier coefficients also, but now we can use this method. Okay, right, v is equal to u k1 u1, we will see k1 u1 plus k2 u2 plus k3 u3. Now v is nothing but 9 minus 3 16 is equal to k1 u1 is nothing but 1 3 3 plus k2. Now u2 is 2 5 negative 1 2 5 negative 1 plus k3 into, now u3 is 4 negative 2 4 negative 2 3. Now what we have to do is we have to scale vector u by k1 and scale vector u2 by k2 and vector u3 by k3, and the resultant vector should be added together, right? So 9 is equal to k1. Now I am just multiplying this and this and this and this and this and this. So k1, and then we have to add, right? So we have to add k1 plus 2k2 plus 4k3. Again minus 3. Minus 3 is the y component. So 3k1 5k2 minus 2k3 is equal to 3k1 plus 5k2 minus 2k3. Then z component 16 is equal to 3k1 minus k2 plus 3k3. Now if you go to setup mod and then 5 and then 2, you can enter these coefficients and constant so that you can find x, y and z. Then we have to transform the values to k1, right? So simply we have taken k1 k2 k3 and k3 as x, y and z. So now if you simplify these three, let's do it together, right? So if you want, you can write this way also for easiness, right? So you just write this constant in the right hand side of the equations. That is the conventional way of writing an equation. So this will be 9 minus 3 and 16. Now we can enter the values. 1 equal 2 equal 4 equal 9 equal 3 equal 5 equal minus 2 equal minus 3 equal 3 equal minus 1 equal 3 equal 16. Okay, x becomes, have I made any mistake? Before that, let me check. 9 minus 3 16, k1 1 3 3 2 5 negative 1 4 negative 2 3, and k1 plus 2 k2 plus 4 b3 is equal to 9 3 k1 plus 5 k1 minus 2 k3 is equal to minus 3 3 k1 negative k2 plus k3 k3 is equal to 16. So now if I simplify this, x is equal to k1 is equal to minus 3 by 89 minus 3 by 89 now y is equal to k2 is equal to 24 by 89, then z is equal to k3 is equal to 189 divided by 89, 189 divided by 89. Okay. Okay, so We have a theorem 1.1 related to the addition of vectors, addition and scalar multiplication of vectors. So the first one is u plus v plus w is equal to u plus v plus w, which means this is associative. Scalar multiplication, vector addition is associative. So I can verify, I can just prove these theorems. Sometimes they might ask to prove this theorem in your examination. In our first tutorial also we have a question like that. Right. So if I take u is equal to a1x plus b1y plus c1z and v is equal to a2x plus b2y plus c2z and w is equal to a3x plus b3y plus c3z. Now I have to take the LHS, right? So if I take RHS is equal to what? U plus V plus W, which means first I have to add U and V, then with the resultant vector I have to add W. So U1 V1 means A1 B1 C1 plus A2 B2 C2 plus W means again A3 B3 C3. Now A1 plus A2, because they are the corresponding element, A1 plus A2. Then with that I have to add this B3 also, A3 also. Then comma B1 plus B2 plus B3, B1 plus B2 plus B3. Then again C1 plus C2 plus C3. Now if I put parenthesis here, if I add these A2 and A1 first and then if I add with the A1, so it can be written as how? U plus V plus W. That is very simple. U plus V plus W, which means first you have to add V and W and then U. So when we are doing tutorial, we will be doing much questions like this, and in the next video we will be talking about dot product and cross products. So hope you enjoy this video. This is just introduction to linear algebra, and from the next video the videos also will be going interesting. Bye.